guys, Stanford here with the Fun Robotics Network, and welcome back to an episode of Behind the Bumpers. And today I'm checking out with Team 6995 Nomad, and we're going to be taking a look at their really cool pivoting elevator on this robot, their wrist, end effector, climber, the software that powers it all, the sensors. They got game piece detection going on inside of this robot, all kinds of crazy stuff. So stay tuned for a look at all that and more on an episode of Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following.
AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions. Earn up to a $5,000 sponsorship for your team or a $2,000 individual prize when you provide a video submission to the Altair Global Student Contest at altair.com/contest. You can build better robots faster with Altair tools and provide multiple video submissions for the contest. Download Altair tools for free. Scan the QR code or go to altair.com/contest for further details.
All right, Saul, go ahead and take us through the base of this robot.
Yeah, so this year we decided to go with the swerve drive base just for maneuvering around the field and easy for auto align. This year we have a 28.5 by 28.5 drive base. We're running SDS MK4i modules with L3 modified gearing, so we get more speed when we're cycling. We are also running a brain pan design. This is really helps us out because when the coral is up top, it can fall down and damage important electronics. So the brain pan design keeps it protected underneath, and it also opens up a lot of free real estate for any other mechanism we want to run on top. Additionally, it keeps the wiring clean, so there's almost no wires above the brain pan. And then moving up to our LED panel, which is kind of the next step, it's actually pivots, so we can access the battery and the main breaker. Also, you can see underneath, this is the start of the pivot gearbox. So we are running our pivot with 4 Kraken X60s on a 123.456789 ratio, just because we want speed and power. And so we're running 135 chain to pivot our elevator. So one thing we actually realized early in the build season is that when we go to climb, because we use the pivoting elevator to climb, the 4 motors with brake mode isn't enough to keep our robot up for 3 seconds once we're disabled. So one solution we had to this is this brake in here. And this brake is just a rubber pad on a lead screw pushing into a metal hex hub, and it jams up the system here. So we went with a Vortex here. We normally like Krakens just because they're great motors, but Vortex is nice because it's a free spinning motor and we can manually adjust it when setting up on the field. But this basically is just like a West Coast Products fish and bake on a lead screw, and it's geared early into the reduction, so it doesn't have to do a lot of force. And that's pretty much for the brake. So at the beginning of the match, we disengage it, and then when we go to climb, we re-engage it. And then leading up to the elevator, we have 2 Kraken X60s, again, powering our elevator on a 3-to-1 ratio. It's chain driven, and it also has 2 6-pound constant force springs to lighten the load and make it go up faster. It's cascade driven, and next up is our hand. So
Really quick, so the one chain that's powering all of this, how are you keeping that tension in this setup?
yeah, so our team really hates slop or backlash, so we love tensioners. Anytime we can do an inline tensioner, we like to, so that's what we did here. This is just a turnbuckle in the chain. I can quickly go to the pivot chain too. This is heavily inspired by 2910 tensioner in 2023, just modified to fit our geometry. Just tightening these 2 bolts will pull a chain in, and when we go tighten this guy, it will tighten the chain. One more thing about tensioning, we have this Dyneema. And that's tensioned by this little ratchet here. So we have tensioners everywhere. We love them just to eliminate the backlash.
All right, awesome stuff. And let's go ahead and talk about this end effect that you guys got.
Okay, yeah, so this is our hand. We use it for both coral and algae. As you can see here, it's driven by a Kraken right here. And it powers the gears. It actually goes through bearings in here, comes out this side. A belt that drives some more gears, and then up in there there's another gear that drives these belts on this static 3D printed gear. Yeah, and then yeah, let's do some positioning for this guy. So this is our intake position for coral. We come straight up to the coral station, and then we actually have two positions. One is the angle for the arm is designed for when we are one coral away, 4 inches away from the coral station, and another one is for when we are directly flush against the coral station. Yeah, and then we have this is our ground intake for algae. So it just comes straight up. We'll drive into some algae. Yeah, and it sucks it up really well. Here we can demonstrate it. It'll just come right here and boom. Yeah, and then that right there is our barge score. Because of our elevator and how it's 2 stages, we don't quite have enough height to just go up to the barge and drop off the algae. So we as you can saw, we have the elevator go up and release the algae immediately after the motion, giving it a lot of momentum that gives us that extra arc to get it right into the barge. Yeah, and then our coral intake again. Really solid intake, works really well. And then scoring positions, L1 through L4. And yeah, I guess that's the hand.
So this question I like to ask a lot of teams, especially this year with all the game pieces and stuff we got. How many iterations did it take for you guys to get to this point, and what were some of the things you threw out while you were working on this?
So the hand is the most difficult part to design on the robot. We went through 7 different versions of the hand until we landed on this. Biggest part of that was because we realized we wanted to take algae off the reef and hold it. Initially, we were planning on just knocking it off, but strategically, it was best if we could hold it. And so, yeah, it took like 7 versions to get here.
All right, very cool stuff. Let's go ahead and take a look at some of the sensors and stuff on this robot.
Okay, so right here we have a time of flight sensor. This measures how much the coral is offset when when it's intaking. So that actually in the code adjusts our auto align, so it always goes into the correct position. And that brings us to autos. So we use this thing that we call flex auto. So basically what it is a bunch of point-to-point paths in choreo that we can string together for any autonomous. And we also use auto line for those.
So what is this flex auto system actually? It sounds really interesting. So is it kind of like different chunks of autos that you can all kind of build together? Or is it something a little bit more advanced than that or something like that?
So it's basically just point-to-point paths in choreo. We generated paths for all the possible starting and scoring locations. So for our autos, we can basically string them together for whichever side, whichever alliance, and this even enables us to do things like doing a push auto, where if we're ever partnered with a robot that does not leave, we can push them and get that auto ranking point. And then one more thing that's very that this is also very useful for is if we're ever making any, like if we ever need to tune our autos or change our autos, we can only change one thing and that updates it for all our autos.
All right, really awesome stuff. Let's go ahead and take a look at all of the controls and stuff that you guys use for this.
Okay, so over here is our driver station. You can come a little closer. So we have our driver station laptop. We have an Xbox controller for our driver. And this side is for the operator. This is our button board. And so first off, we decided to go with a layout of the reef. So when we want to select a place on the reef to score, all the operator has to do is pick which place that would be, and as you can see, it updates on our driver station. Now these are just corresponding to the different levels. So mid-match, let's say we wanted to do L3 right in the back, boom, you're done. For these buttons down here, this is our climb sequence. So this just pivots the arm up. This will close the claws for our climb and pivot the elevator down. And this last button is for the brake. So even after we get disabled, it's still gonna hang on to that page. Over here, we have a switch, which was demonstrated earlier, but this basically changes how much our elevator is like kind of pivoted. So we can either slam right up into the wall to intake coral, or if we switch this, if there's one coral, let's say like sideways, just blocking us in that coral station, we can still intake the coral. So that won't be a problem for us. And then one other nice thing about this button board is that it almost functions like a whiteboard. So as you can see here, we have labels for all the different reef locations. So that makes comms a lot easier, because then the operator doesn't have to think like, oh, is this near right, near left? No, you have it right here. So it makes it a lot easier. And then you can also draw out strat. So for example, let's say we're with an alliance and maybe we're gonna work on this side, divide the field in half. So now we know we're working on this side. Maybe our autos, 3-piece auto, boom, boom, boom. So we know those would be done. And let's say we're gonna move from back to front. So that just makes the job of the operator a lot easier. You don't have to think about as many things in match because it's all written out for you.
All right, guys, so that was your look at this NOMAD machine. These guys have been looking great here at the San Diego Regional. Their third regional so far this year. Already took victory at Orange County a couple weeks ago. So check these guys out at Champs. These guys have been looking really, really seriously good off the field. So thank you guys so much for allowing us to come by and take a look at this, and good luck with the rest of your competition.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Earn up to a $5,000 sponsorship for your team or a $2,000 individual prize when you provide a video submission to the Altair Global Student Contest at altair.com/contest. You can build better robots faster with Altair tools and provide multiple video submissions for the contest. Download Altair tools for free. Scan the QR code or go to altair.com/contest for further details. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions.